and actually capture the arguments to different calls. So for example, there's this function called check root. If you run the application normally, right, you try to run it, la 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 la, and you write begin, like it will say root detected, your device is rooted, you have to close your app, and it closes the app. But let's say you have FIDA. So what you can do is, not here. So you can download a wrapper for FIDA called objection. So it's kind of interesting too because it makes FIDA actually usable, like easier to use. So you can launch the application and then you can sort of intercept the root checks. So previously there was this function called check root in main activity. So you can always make it return false like this. And it tells you, hey, I'm hooking on to check root, and then I'll always make sure it returns false. So let's say you run this now. Then it stops complaining. So that's one trick you can do. So the thing we're interested in is like the admin login, right? You can of course use the SQL injection, but actually that's too lazy.
Yeah.
What you realize is that if you SSH into the thing, and then I think it's data, like the databases are stored here. So the admin database is actually stored here, and if you just file user accounts DB, it says it's data because it's actually encrypted. I'm not going to show it here because there's nothing to show it, but it's an encrypted database, and they use this library called SQL Cipher. So you can look up like ways of like decrypting these things, and it's supported in some database viewers. But you first have to get the password. So how do you get the password? You basically intercept the call to each time it tries to access the database. So in this case, you can find this command online. I'm not doing anything special. So you hook and watch for this whenever it opens the database, and then you ask it to dump the arguments. So you press enter, yeah, and then next you just type whatever you want. It doesn't really matter. False, whatever. It's not important. Did I dump the correct thing? Let me see. I don't think this is correct. Yeah, open or create. Let's try this. Yeah, anyway, if I hook correctly, and this is the password for the thing, you can put into Python. Let me just open a new tab, Python 3. Maybe I should call it A equals to this, and then join for I heard a beep, so I thought something bad happened. But anyway, yeah. So you can actually just get the password. This is the password. You copy and open this thing called data SQL. But what tool I use? DB browser for SQLite. You open this. You open this. You open the database. You can download the database from the device itself. I won't show you how. You can look it up online. But we have the password. So you can just select this, copy, paste, okay. The users is here. You browse the table. There's the password. Yeah. And then basically you do this for all the other challenges. Yeah, you can key in the password here. I won't key in because it takes a longer time to key in the password than to actually get the password. So yeah, so that's the so-called right way to do it. You can perform the same tricks for most of the rest of the mobile challenges.
Wow. Okay.
So honestly, there are more than one. What did they leave the SQL injection vulnerability there then?
I think it's just to make it easier for like it's like the SQL injection is something you can do even if you have no mobile experience.
I agree.
But that's not really a mobile challenge, though. Wow, that's a lot of new tools there. Oh my god, so interesting.
Then
Anyways, man, yeah.
you can do the rest of the challenges as well using the same tricks. So for example, like I don't know what other challenges are there. Let me see. Let me look
Oh,
at
there's
the list of
the
challenges.
info one.
There was true or false. What else is there? Actually, some of the other challenges are more annoying. So like the task A to Z or COVID, all of them require some kind of reverse engineering.
It's all painful, essentially.
Sorry, what?
Wouldn't be. It's all painful, painful challenges.
Like some of it is like you need to know the shortcuts. So I can show you some.
Shortcuts.
Yeah. I can look. Let me show you some of the challenges. Let me just share my screen again. Where's my screen? Okay, so for example, yeah, you actually need IDA Pro. Like, if you don't have IDA Pro, like, this is actually very painful. I agree. But with IDA Pro, right, everything is not too bad.
What about
Uh,
Ghidra then?
Ghidra should be okay. Yeah, it should be okay. I think you should see roughly the same output. If not, you can just don't quote me on this, but you can always ask the internet for help or how to download IDA that is yeah, but a lot of it is like you just need to sit down and not be too scared of it. Like for example, this is the task activity, I think, challenge. So this kind of thing is usually like some sort of stack protector. If you just look at it enough times, you can see, you can recognize it. But trust me, this is some kind of stack protector. Then it takes in some input. You don't have to care what it is. It's some buffer. Then it encrypts the thing. This is already there before, so you can look at encrypt, and then you can click on encrypt again. Then you can try to figure out what they're doing. So it's a bit annoying. But basically it's trying to produce some output. So you basically reverse the sequences. Uh, yeah. I mean, that's not very helpful, but you need to sit down, right, and then write out the equations for what is out I plus one, out I plus two, or out I plus three, and then solve for in the basically the in buff, which I should have some here. Yeah. So you just solve it in terms of in, and then you get the way to reverse the encryption.
Speaking of the reverse engineering, right? I'm kind
Yeah.
of curious about the whole binary exploitation challenge. The one
Oh,
where they give you a Linux the second binary exploitation one, not the first one, the second one. Any idea what that one?
oh, I didn't do that one.
Oh damn.
I'm sorry.
Good
I
one.
think there was like there were some people that tried to do it and then they gave up because like I think there are quite a lot of annoying things inside. Like uh they put a lot of like the trap uh instructions. and then you can't really debug properly.
How can I ask for the reverse engineering? I think there was one about the HTML, the very first one, the HTML and the JS. What's the are we supposed to do for that? I just yeah.
I think I did it in a way that was not the fastest way. I think there are a lot of faster ways of doing it. I think someone used like this thing called D for JS or something. So if you use D for JS enough times, you should get like the decrypted output. I did it manually, which is a very screwed up way of doing it. Let me see if I still have it.
Wait, so the point of it is
Um,
to debug it or to decrypt it? I'll try to
Um,
debug it.
It's
But
I would say that it's just more of like trying to make the code not so messy in the sense, like more readable. I don't know Whitehat if you did the same method as I did.
yeah, I did it the same
You
way.
match the array, right? Every array, then you go and match, then you write over.
Yeah.
Yeah.
That's
Oh
what
my
I did. It was very painful.
I never want to touch that again. After I did that part, I gave up on RE already.
But I knew like, oh shit, like this can be done. Like I just had to do it. Maybe I shouldn't be doing it this way. Maybe I should just like write a program to do it. But I did it halfway already. So
Yeah.
like, fuck. just continue. So.
Yeah. I gave up and then I just gave to my the other teammate. Then I think he also figured to use some program to do it. Then I was like, okay.
Yeah, you just have to like you just have to match on each of the words and then just
Yeah.
replace the words. Like
Correct.
they even have the regular expression for you to use. Like it's in the thing.
No.
But you
oh,
like
so as long as you match everything in the array to the appropriate thing, to the appropriate call or the array call, then they will just run like that. Is that how you're supposed to solve it, or
so after that, right, there'll be like some input in array. Like I don't let me see if I have the code somewhere. I should have it. Give me 1 second. Code. Yeah. Let me share my screen. Excuse the file name, but it is what it is. Yeah, so after that you transform to some input vector x, and then it will assign it some value based on some previous thing, like do something or some value, and then this x, right, will be passed into this function I, and then if it's the correct x, it will output flag. So you just need to brute force it's either one of these x's that's correct. Yeah. Does that help?
wait, this looks so different from what I saw. Like the one that I was looking at had like 37 things in the array, right?
Yeah, correct.
Oh,
About 30
oh, then
something.
it will look like this after all. What?
Yeah. So after that, there will be like a part where there will be like a transformation of from one map to another. I don't have like let me see if I can find the original one.
So there was no error in the array at all. Like for example, I
Yeah,
remember the canvas was like class G, but then in the array it was written as GG. So I was thinking that I had to like change from G to G,
uh,
GG from to G,
I
something
get
like
what you
that.
mean. I get what you mean. Yeah, it's kind of fucked
Yeah.
up because the code is broken. Like, they replace it with things that isn't like that. Like, for example, if you just try to run the code directly, it won't work because one of the functions is supposed to be something else, like eval or something. I can find reverse engineering and invitation.
So Whitehat, can I say that this is like obfuscated code in a sense?
Yeah,
That's
it's
why.
obfuscated code.
Yeah.
But I
So
mean, like their obfuscation is annoying because they also introduce errors into the obfuscation. Like for example, like if you look at the original source, the invite.js, right?
yeah.
Like that code cannot run.
Yeah.
It's just like why would you do this? This is screwed up.
Yeah.
Like it just annoys you. Like you don't know what the fuck is going on. Then you just have to follow. And you
That's
can't debug it. Yeah. But eventually you should get to a point where you can debug it. So what you can do is like remove the parts that are obviously cannot be called. Like
Error. Right?
remove the parts that are erroring and then like just isolate it to one function and then you call that function. And then you can use the what do you call it, developer tools to debug the code. Yeah. And that'll work.
Wow.
But that was annoying. That one pain. That 1 hour of pain, man. What else was there? Any other interesting challenges? I think the crypto is kind of trash. The last crypto was kind of trash. Do you guys look at it?
My team didn't get past the first crypto.
My
The-
team didn't get past the first crypto either. We got confused. Like I said, yeah, the
the
flag
DH one.
was. The crazy thing is we actually got the secret that was shared, but the instructions were unclear, I guess, or like maybe I misread it. I
Yeah, well,
completely missed that the flag was secret. Oh well.
I don't blame you. I think it's stupid that they just can't make they can just make the key the flag. Like it's not difficult. Like they can
And
just
the
turn
crazy
it
thing
into a
is,
format of a flag. Yeah. Yeah. The crazy thing
and the
is,
crazy thing is that like in the flag submission, right, they put it's alphanumeric. So I was looking for like an alphanumeric code somewhere. I don't know. I got a string of numbers. I thought it was just part of the solve. Oh well.
I recall them putting numeric.
maybe they change halfway. Just
Yeah, maybe at the start they put alphanumeric. They realize, oh, GG.
too many people complain.
Who else?
For those who don't know how to solve the first one, I can
What was
share
the
my
last
screen. Let's look at the first crypto first. Wireshark. I think I can still open this.
I can share this one. This one I can solve this
Okay.
one. Thank God.
Yep. I'll let you share then.
Share content, share screen one. Yeah, so for crypto, it's really just about analyzing the packet first and getting it. So essentially, we look through all the content, right? We notice most of it is TCP, so we just filter out for TCP stream. And you can kind of see there's like one stream here, there's one stream here, and there's an embedded stream here. So to first check this out, right, we get this message, if you click follow, it shows you the entire like thing, PG, GAGB, and where's my edge? Yeah. So if you expose this, you get this. Edge for school stuff, Safari for my other stuff, but yeah.
Oh, okay.
So then in the second stream, you can see that there's a file being transferred.
Uh-huh.
So it's FTP, no encryption. So you just look for the stream, and then you can find the zip file. Then you can verify it's a zip file using the signature. And if you extract it, right, you can get a zip file. So the zip file, once you get it, you actually kind of start because you have a password on it. So based on the text, based on the conversation, right, they said that the password to decrypt the file is basically just the shared key. And for Diffie-Hellman, essentially what the idea is that you can have multiple public values that are transferred across the communication, but then there's a secret that is sort of like hidden because of math. And I'm not sure if I should like explain the whole Diffie-Hellman algorithm, but essentially there's a pretty good analogy where you mix paint. So let's say you have two hidden cans of paint, then you have two publicly available colors of paint. Then you just mix the paint together and you send the mixed paint across, and then the other person mixes that paint into it. And ultimately, it should be like the public paint plus the two secret paints, and you should get like some shared secret essentially. But bad analogy aside, we noticed that the P and G is actually quite small, so it shouldn't be too computationally expensive to crack the secret now. So from I think I got some help with like figuring out what calculator to use, but essentially there is this Alphatron, which essentially lets you look at all the different there are multiple calculators to solve a lot of things, but this one lets you solve for the exact equation we're looking for. So Diffie-Hellman uses an equation where they take a base. So in this case, the base is G, and you take an exponent, which is essentially what we're looking for, A. And they also have a modulus, which lets you put in P. So I just put in all these values. Put the modulus P, put the power, which is this. Let's say I'm fitting for A, this, and put the base into this. And then I just run it, right? And then it gives me this value here. So the exponent is basically just, this is the secret variable A. So once we get this right, we can basically say A is basically this value. And then to find the secret is basically based on Diffie-Hellman, it's G to the power of B to the power of A. So you take this number, put it to the power of this big ass number, and then modulus it by P, and you get the secret. And when you get the secret, you can decrypt the file, and you get this image. So I spent a fucking long time looking at this image and wondering what the fuck is, sorry, minor language. What the hell is this like? What is this like? How do I get this?
Oh, don't worry.
Literally,
Like
I look at
even
like
even the OpenCat, right? Like the cryptography experts, they couldn't even understand what the fuck was going on.
yeah, and I was looking at this like wondering what does the X mean, what does the plus mean? I was looking at like logic gates. I was looking at like multiple. Maybe this is the 500 length key that he's putting into Sn-1, Sn-2. Yeah, but it turns out the flag is just the secret you use to
Open it.
open the file. Yeah.
Oh my gosh, you fell in the rabbit hole.
You also couldn't figure it out, right?
No, my team was quite stuck because we knew how the equation worked, but we just couldn't figure out how to get the A. Yeah, so
Yeah.
we didn't know that such a calculator exists. I know it has something to do with some algorithm or something. Then I was like, oh, I really cannot find. Then crypto is really like my bane. So I just don't waste time now. We move on to another category.
Yeah. Okay, so I guess I will never know what the other challenges for crypto is.
I think it's a lot now. But I mean the last challenge is like really just it's quite trash. Like I bet you guys can do it.
Explain.
Let me share my screen.
Take over, yeah.
Do I take over? Yeah. So this is the challenge. COVID has been caught exfiltrating an encrypted message back to their servers. Let's find out what it is. Most of it is like you don't even have to access the web service. Like they messed up the challenge. Yeah. But anyway, so if you want to solve this, you type what is P, you type what is Q. And N is P times Q. Then you need phi of N, which is P minus 1, Q minus 1. And you need E, which is 345, G7, I think. Yeah. And then you need to take the inverse, which is D. So D is mod inverse E in phi of N. Don't ask me why I can memorize RSA. Oh, I need to type it out. Huh? I forgot what it's called. Oh, inverse mod, right. So you have D now. So how do you need to read the file? I think I'm a bit lazy. I think this is open. Twitter. Code base64. Oops. No, I'm very sad. Then encode as hex, and then take the integer of that. Okay, now you have the integer form. So this ciphertext is this number, and the plain text would be like that number.
He disconnected.
Nice.
Wait, the Whitehat just get kicked off the call?
He disconnected from the call. I don't know why.
Oh no.
Like,
I guess.
don't tell me his laptop died or something.
Did anyone see his battery percentage before he left?
I didn't see.
Yeah.
Because he just suddenly like, then leaving.
Well, I guess before he returns, let's try to figure out any other challenges. So besides, let's put the challenge you're solving on hold. Any other categories that you guys are interested in reviewing or like discussing any of the solves?
I want to. Oh,
Yeah,
sorry.
go for it.
I wanted to ask, right, for mobile challenges, would it be a good idea to try to decompile and then try to like print out what they're comparing?
Actually, that's what Whitehat showed just now. Using something called Genymotion. So I also learned this just now, but Genymotion essentially lets you run a emulate x86 hardware on a Mac, or I think that there's definitely equivalent for Windows. Essentially what he did was he used ADB, Genymotion, and an objection to bypass root checks, decompile the application, and also he ran the application on Genymotion and then traced all the different like system library calls. He reverse engineered the code, and he also extracted data out of the APK. And using that, he solved the mobile challenge also. And according to him, it's pretty standard way of solving most mobile challenges. So once you learn that, I guess you can tackle most of the mobile challenges.
See.
He also mentioned the use of Frida, but I think that's more for reversing purposes. Also.
Ida or Ghidra is more for reversing, yeah, but that one is more if you're into reversing.
So you all don't like build a new APK with like the changes. You just like inspect what's going on at the moment.
I don't think you can make changes there, from what I remember. But okay, I could be wrong.
Essentially, you just what he did was he ran the APK that's provided, and then he just used all the different debugging tools, right, to figure out like what the program is doing.
While it's running. Okay. Okay.
Yeah.
Thanks.
Hold on, let me message Whitehat. I think he's been off for quite a while. Let's see what's going on.
I think there was a group that managed to decompile and change the jump instructions on the assembly code level, but I think that is quite difficult. I don't really understand that also.
Nuts lah. And in case you're curious, right, the challenge site is still available to play. So like you can still go onto the challenge site to look at all the different challenges.
Mm-hmm.
Oh, he's back. Welcome.
Yes, Whitehat's back. Wait for him to connect.
It's muted, I think.
I don't know.
I thought you're muted.
Hi, I'm not going to Richard anymore. So that's not.
Okay. Just before you put in the value for plain text.
Oh,
Yeah.
okay. I mean,
your laptop died, is it?
no, my laptop didn't die. My laptop was fine. But Microsoft Teams just randomly
Close your.
disconnected.
Give up.
Yeah. Yeah. You copy the plain text, you put it into. I mean, if you can do it in Python 3, you can, but I don't remember the exact command. So I put in Python 2, and then you decode hex, you get the flag at the end. I mean, the moral of the story here is that always, if you see RSA, just check the public key on FactorDB in case it's factored already. Once you have P and Q, you can basically decrypt the plain text. I think they had a different idea for the challenge where you do some kind of padding oracle attack, but I think they didn't implement it correctly. So
Wait,
Yeah.
FactorDB is a database for all the different like.
yeah, it's like Wikipedia for numbers. I mean, it's not really Wikipedia for numbers, but yeah, if a number has been factored before, then it's there. If it hasn't been factored yet, then it's probably not. The solution is probably not to factor it.
Cool shit. All right.
Yeah.
Okay. Nuts. A lot of experience,
It's like the first few things to check. But I mean, you guys are also just starting out. Like once you guys see enough of this, right? Like you guys become experts, like in a few years time.
Wow.
Wait a while. I was also a noob once.
Slowly
I'm very old already. I got beer belly and then balding. I got receding hairline. So like, so that's the difference, guys. It's age. No, it's not a factor of being smart. It's just a factor of age and experience. So you just need to see enough, or you just need to ask someone who has experience to show you, which is the purpose of this sharing as well.
Yeah. Well, I thought for the webs, on the web one, right? Do you manage to solve any of it?
Which one do you want to look at?
The ransom one, the one that you have to crack and find the ransom key.
I solved it, but it's not very convenient to show the solution. But I can
Okay.
guide you through it. Yeah.
Okay. Because I've been looking at it, and I'm like, how do you? Okay, maybe the hint to start off lah. Like where would you look on this case?
So it's actually I was also tricked by it like for like 5 seconds. I mean not 5 seconds, but for like
5
half a
seconds.
day.
Okay.
Wow, 5 seconds like
Half a day, half a day.
second.
I mean the reason why I got tricked by it was that like I think I tried something like
Yeah, I can
that
see your
equals
screen.
or something. Can you see my screen?
No.
Why equals?
Oh, I think it's me. Yeah, let me.
Wow, but
Sorry.
kidding.
I really can't see it. Oh my gosh, why?
I can see COVID ransom help desk.
I can reshare then.
I think it's me, because I'm using the web browser version.
I'm also using a web browser.
Really? Oh my
I can
gosh.
see it. I can see.
I shared again. Can you see?
It should be palm the recording.
I only see Whitehat's face.
Oh, no.
How can you see my face?
As in your DP.
You can restart the thing and then
Okay, wait, let me hang up and call back.
But before we continue, like, why bracket enter? Like,
I initially thought it was like no SQL induction because what I tried was like something like not equals, and then it showed this is fine. Like if you look at the payload, all the things. No SQL.
Okay.
Hi, can you see the screen?
Yes, I can see it now.
Very good. We were saying, why did I try this nonsense here?
Oh,
The reason why I
lot of
tried this
things.
nonsense is because I tried this kind of nonsense. I thought I was injecting it this way. And I thought, wow, I managed to get a no SQL injection. So I tried that for a while and I realized this is not it. This cannot be it. So, you guys see this thing on the left?
Yeah,
It's actually, like, do you guys know what it's for?
it's
For the ransom.
yeah, like post. It's a post form, right? Like post a form or something that you submit.
So, it's a good site to know is whitehat.site. I'm not sure if you guys know it already. Basically, you can, let's say if something makes a request to you, right, you can actually, it's actually recorded here. So you can, like, if you're lazy to spin up a server, you can just use this, something that is really quick. You key in here, you key in some rubbish. This has to be an email. Of course, please, you can use proxy and make sure that you can resend this again and again. I'm just doing this because I'm lazy. So you send the hack website URL, then it actually makes a request to that website. So they don't provide this for nothing. So obviously we need to use this somehow, right?
Mm.
So the goal here is to leak the admin's cookie, or
Yeah.
not really admin's cookie. You can't actually leak the admin's cookie, but to
Put
force
in.
him to leak this hidden value, right? Actually, this hidden value. So you should look at the how this is implemented. So first thing you will notice is that I should just go here. So this is in an iframe, right?
Yeah.
So usually in an iframe, right, it's considered in its own sort of context. But this thing, right, somehow is able to communicate back to this part of the thing. And if you look at this part of the thing, right, this part of the thing is actually outside the iframe. How you communicate across different frames or iframes, right, is through this messaging system called. I can show you. I don't know if I can show you. I saw it just now. Eh, eh. Yes, this messaging system called post message. I'm not sure if you guys heard of it before.
Okay. No, never do
Okay.
much fun and stuff.
Yeah, so
HTTP poster.
So post message is an internal messaging system. It's nothing related to like post in terms of HTTP, but it's just internal within the browser itself. So this sends a message to the parent window. Window is like the global object in browser, and like so this iframe has its own window. The parent of this iframe is this outside frame, correct? This big frame. And then it sends a message saying that, oh, this is dumb results and this is the origin that should be able to accept this message. So any origin can accept this message. Origin is this thing here.
Hmm.
And with the pod. Just to be clear. So this thing, right, would also have its own what do you call this? Event listener. So it looks for not this event listener. There's another event listener. Yes, this event listener. So it looks for this event message and then it updates the event data. So you need to put the pieces together, right? There is a browser that accesses your website. The browser, you just assume it to be the admin. Like it's hinted here as the admin or somewhere. If I can find it. Our customer service will check it out. You assume that customer service has the key, right? And key, and only the customer service can access the hidden fields here. So you must somehow leak this thing via via this post message mechanism. So what you can do, right, is that you can host a website and then you embed this iframe.
Ah,
Oh.
So this iframe, the source actually is /flag, q equals to flag. Right, if you just visit this page alone. Right, so I mean, you can imagine this to be part of an iframe as well. So there's a parent frame, and then you customize your own event listener to keep track of like what has been queried so far. So for example, you want to brute force the flag, right? You would say, oh, you try A, you try B, try C, etc. Of course, like the flag starts with GovTech, so you try GovTech, the CSG, then you try A, try B, try C, something to that effect. But you need to try it from the parent frame.
Oh.
So, I mean, I can show you the source.
what the?
Wow.
I still barely understand this here.
Yeah. It's a bit
I
hard to
still try.
understand, especially
Still try to wrap my head around it. So.
okay. It's a bit hard to understand because like this post message mechanism is a bit of a weird thing. Right. This thing, right, will send a message to whatever parent. Okay. So the iframe, right, is it's like you can embed it anywhere, and you can embed an iframe, like for example, let's say you're on google.com or you're example.com. You can have an iframe on your HTML that
Oh,
embeds this thing. Let me just
so essentially the web page is asking for its Windows parent,
yeah.
and then it's sending the number of results.
Yeah, so your malicious page will embed this iframe, and then it will modify this part until it finds the flag.
The full flag.
Until it finds
So
the full flag.
it's really just
Oh.
brute forcing.
Yeah, so this is what I'm doing. This is the body. I'm embedding the iframe. So how I iterate through the guesses is that I just set the source of the iframe. So if you look at how the iframe is loaded, not this one. Yeah, it's through
Yeah.
the source. Source equals this. So you just change it. If you look online, also like on Stack Overflow, they'll tell you this is how you change the URL on the iframe as well, and then get it to load automatically. So you just brute force. You have a guess, and then you guess the next character, and then if there's a result that is returned, it means that you guessed correctly. Then you can add it to your guess, and then you can so on and so forth. You do this in a loop. Yeah, but you just need to be a bit more attentive. So this is a classical case of what they call access leak, cross-site leak. So this is the place that you're trying to leak from, but your parent frame doesn't have to be from the same origin. So it can be like, say, for example, evilsite.com, and then like it will load this, and then like the attack scenario here is that, let's say you are a user, you accidentally click on the website, or you're redirected to a malicious website. They can actually steal your secrets through this access leak. So for example, this could be your bank account number or your credit card number. Yeah. So that's the kind of adversarial scenario that they're trying to detect here. But rarely people code like this. This post message mechanism is rarely used because no one actually uses. I mean, I would say no one uses it, but it's very rarely used in the real life.
How do you know about it
It's
then?
only used because I was a TA for browser security. so I know a lot about browsers. Yeah.
Oh, okay.
But in reality, it's quite rarely used. If you see it, then like there are some security issues with it. Yeah, but it's very rarely used. I don't see it very often.
Okay. Thanks. been trying to figure out how to solve that. I put like all the different input. Then I was like, nothing's happening here.
I mean, the same thing happened to me. Like, I was wondering, like, what the fuck is this? Then, it's only until I tried the ransom submission that I realized, oh yeah, this is like the way they constructed the challenge is there's only one way that this can be solved.
Jesus.
Too
Really,
OP.
It's okay. We're all on this infosec journey. We're all trying to learn. Meanwhile, I cannot find where's the flag.
Where's the flag?
The stupid ping in the ping.
The Stego one. It's Stego actually.
That was a bit ridiculous. A lot of guessing, I feel. Like,
No, it's a lot of guessing, right? But I couldn't figure it out. And I was like, I saw 80 people solve it. I'm like, what the fuck is going on?
that's okay. There's a lot of mobile challenges, huh?
Yeah, I think that was too much. By the end of it, it was actually getting quite tedious. Like, because after you solve one or two, right, the rest is mostly the same. Like, you reverse or you reverse,
So
or
many
you
points in
read
mobile.
the memory. Yeah, it's too many points. Way too many points. I think the web challenges were quite fun.
Huh.
Most of them. I didn't like a few of them, but most of it was okay.
Did anyone solve any Internet of Things challenges? IoT?
Nope.
Actually, the person who made this was SMU graduate. Maybe I can get him to share one day.
Ooh.
The
Will they
person who made
release write-ups for all the
IoT, is it?
challenges?
What?
Would they release write-ups for all the challenges, or is it just the ones that were solved?
I think the ones that were solved, right, will be mostly be done by the people who actually solved it, like because there's a write-up competition. The ones that are not solved will be written up by GovTech. At least that's the current arrangement, from what I heard.
There's a 3,000 point IoT challenge that was solved by one team.
The
pretty nuts.
RSA one.
RSA
I
one,
would
yeah.
say IoT token. Is it?
Yeah. Anyone knows who solved it, or is it just
I know someone made like quite a bit of progress in solving it. Like,
ran out of time?
I don't know if they ran out of time or they got stuck somewhere. I have the partial write-up. I mean, if anyone is interested.
No.
I didn't look at the challenge. Like, I didn't have time. Like the mobile was so time consuming that you're like,
But you can get a lot of basically a lot of free but tedious points for you at least.
But yeah, the mobile
Anyone
is
else?
it's quite accessible, like native binary reversing challenge. So if you're interested in reversing, yeah, especially if you're interested in reversing, I think mobile is not too bad of like something to start with. Like task. What's the other one? Still, let me get the names of the challenges. Roam, stats, yeah, these three I think are quite good if you want to learn like native binary reversing, like just as a start, because they are relatively small. Like in terms of the challenge, like if you look at the native binary, like it tells you that this is the check flag for stats, or this is the check flag for roam. So like